This lesson we will be looking at what we call mixture problems. And mixture problems are where you take two quantities of something, you mix it together to make a new mixture. Okay? So we'll just kind of do a couple of these and hopefully you'll catch on. Delectable Cookie Company sells chocolate chip cookies for $6.95 per pound and white chocolate cookies for $5.95 per pound. How many pounds of chocolate chip cookies should be mixed with 4 pounds of white chocolate cookies to obtain a mixture that sells for $6.75 per pound? Okay. So, again, I will give you a table when you do these. And so, in this particular example, we've got chocolate chip cookies, white chocolate chip cookies, and then we're going to mix them together and sell them as a mixture. Okay, for a price somewhere between the chocolate chip price and the white chocolate chip price. Okay, so if we look at the question is how many pounds of chocolate chip cookies should we mix? So my question is this. I'm going to put my X right there. You could use whatever variable you wanted, but I'm going to put X because I want to know how many pounds of chocolate chip cookies I'm going to do. Okay. What I know is that I'm going to mix that with 4 pounds of white chocolate. So 4 pounds of white chocolate. And then I'm going to mix them together. So I'm going to add the chocolate chip with a white chocolate to get my mixture. So to get your mixture, to get this spot right here, you will add the two rows above it. So we'll add x and 4 to get x plus 4. Okay? And that's what you will do to get that box every time. You will take these two boxes and add them together. Okay? Now, the chocolate chip cookies I know sell for $6.95 a pound. And the white chocolate sell for $5.95 a pound. And my mixture will sell for $6.75 a pound. Okay? So, to get your total price, you always take however many pounds you're going to sell times your price per pound. So, basically what you're going to do, again, just like in the motion problems, is you will multiply these together to get your end, okay? So 695 times x will be 695x. 595 times 4 will be 2380. And then x plus 4 times 675 will be 675 times x plus 4. Okay, and again, to get your mixture price then, to get this row right here, you are also going to add those two chocolate chip total price and white chocolate chip total price to get a mixture total price. So I will take that top right box there, which is 695x. I will add the 2380 to it. So I'm going to take the white chocolate total price plus the chocolate chip total price to equal my mixture's total price. And once you get to this point, the worst is over and all you need to do is solve. So on the right side, I need to distribute. So 675 times x is obviously 675x. 675 times 4 when you distribute is 27. So here's where I'm at now. And I want everything that has an x with it to be moved to one side and everything else to the other. So I will now subtract 675x. 695 minus 675 is 20 cents x. So there's where I'm at. Then I will subtract 2380. Over here I will get $3.20. And over here I will get 0.2x. Divide by 0.2. And 32 divided by 0.2 gives me 16. Okay, now let's go back up and make sure we've answered the question. Okay, so the question was, how many pounds of chocolate chip cookies should be mixed? So how many pounds of chocolate chip cookies? That's exactly where my x was. Pounds of chocolate chip cookies was x. So make sure you label your answer. So I got 16 and it should be pounds. All right, and one more kind of like this. A health food store sells seasoning blends in bulk. One blend contains 20% basil. Sheila wants to add pure basil. So pure basil means that it's 100% basil. So pure, I'm just going to add this up here, which is 100% basil. To some 20 blends. So she's going to add the 100% blend to the 20% blend to make 16 ounces of her own 30% blend. How many ounces of 20% blend should she use? So here's my question. How many ounces of 20% blend? So I am going to put my X right here because I don't know how many ounces. Okay? But I do know that she wants to make 16 ounces of the 30% blend mixture. So I know that this is 16 ounces. Okay, now, let's say she uses 5 ounces of the 20% basil. If she has 16 ounces total in the mixture, then 16 minus the 5 ounces she's already used means that she would have 11 ounces of 100% basil. If she uses 12 ounces of the 20% basil, then 16 minus 12 would mean she has 4 ounces of the 100% basil. So if we don't know how many of the 20% basil she's going to use, what I know is if there's 16 ounces total, then I know that this has to be 16 minus whatever she's already used for the 20%. Okay? So then, to do the amount of basil again, you will always multiply these. So I will multiply, multiply, multiply. So 20% times x would be, I will write this as 0.2x. 20% is 0.2. 100 is like 1. So basically you have 1 times 16 minus x. 30% would be 0.3. So 0.3 times 16 gives me 4.8. And again, to get this column right there, you will add those top two. Okay, so I will add 0.20x plus 1, which I don't really need, times 16 minus x, and that has to equal 4.8. So I have 0.2x plus 16 minus x equals 4.8. So I will get negative 0.8x when I combine these two like terms right there. 0.2 and negative 1 gives me negative 0.8x plus 16 equals 4.8. Subtract 16. And I get negative 0.8x equals negative 11.2. Divide by negative 0.8. And x equals 14. So go back and read your question so that you know how to label it. Okay, my question was how many ounces of 20% blend? So that's right where my x was, is in the 20% blend. Notice it's ounces, so I will label this as ounces. So if I use 14 ounces of 20% blend, that means I will use 2 ounces of 100% because 16 minus 14 is 2. All right, and that is the basics of mixture problems.